There's one other aspect of friction that I think is a little bit confusing. A lot of the books seem to not really go through this carefully. I don't know why, but I think it's a really important thing to go over, which is a lot of times in these simple textbook problems, they'll simply tell you, oh, the object is moving. And then you can just say, oh, okay, I have kinetic friction, done. But of course, in many cases, in real life and in problems that you're solving, you may not have all that information. It might be up to you to figure out whether the object is going to move or whether the object is going to be held stationary due to friction. So how do you determine whether you have a static or kinetic friction case if that information is not provided to you? What is the procedure? So let me walk you through it step by step. So this is for cases where the question says that there's friction, but it doesn't say what's actually happening in the problem. There's no assumption of whether it's going to move or whether it's not going to move. So what do you do? And the answer is step one, you assume static friction case first. That's because when it comes to the static friction case, you actually have a method of determining whether static friction can or cannot happen, and that's F max. For kinetic friction, you have no way of determining whether your guess is right or wrong if you guess that it's kinetic friction. So you have to assume, or guess if you prefer, that the static friction case is the correct one and the objects are not going to move. And so as a result, when you assume static friction case, what that means is that you're going to set the acceleration equals 0 because it's static, and you are going to don't use any formula for calculating the friction force. So now you actually solve the problem assuming static friction case. What that means is you are going to obtain the magnitude of the normal force and the friction force under the assumption that it's static friction. And next, you calculate F max, which remember is the coefficient of static friction times the normal force. Let me just write that in here. So then you calculate F max, which remember is mu sub s times the normal force. And now remember, F max represents the maximum possible value of the static friction force. So why would we want to calculate the maximum possible value of the static friction force? Well, because we calculated a value of the static friction force here. And then we calculated the maximum value of the static friction force here. So next, you compare those two things to each other. So next, you compare your value of the friction force to the F max, the maximum possible value. If F max is larger, that makes sense, because F max, remember, F max is the largest that value can possibly be. So if F max is larger than the real value, that makes sense because the maximum should be larger than the actual value. So if F max is larger, that makes sense. Your assumption of static friction is correct, and you are done. You have solved it correctly. If, on the other hand, space this out a little bit more. If, on the other hand, F max is smaller than the friction force, that makes no sense. That cannot be. Something is wrong. And what went wrong is your assumption of static friction is incorrect. You have solved it incorrectly. But that's okay, because now you know that you've solved it incorrectly. incorrectly. And since you know you've solved it incorrectly, you can go back and correct your work. So how you do that is you throw away your value of the friction force that you calculated, because we just proved it's not right. And you resolve the problem from scratch under the assumption of kinetic friction. So you basically proved that it can't be static friction, so therefore it must be kinetic friction, and then you redo the problem. Now that doesn't actually, it's not as bad as it sounds, because if you are careful about how you solve the problem and write out all your work, you'll actually find there's only a little bit of your work that needs to be changed for the assumption of kinetic friction, as long as you did it very carefully, step by step. Sometimes you only need to change a few lines in your algebra, scratch out a few lines and replace them with something else. Generally, the normal force is still okay that you calculated because it's perpendicular to the friction force, so it doesn't actually have any effect on the parts that will need to be changed. But what you'll need to do is A is not going to be equal to 0, but the friction force equals mu k times Fn. So you're basically gaining one variable by having to put the acceleration in, but you're also losing one variable because you're able to plug in for the friction force, and it'll still be a solvable problem. Okay, so that's the basic process for handling this. I also have, if you want to look at the lecture note packet, I made a little flow chart here in the notes to help you kind of keep track of all this information if you're kind of like something that's a little bit more visual. So you start here in the flow chart. Does the problem say whether the object is moving, stationary, or just barely standing still? If it's moving, use the kinetic formula. If it's stationary, set acceleration equal to 0, but don't plug anything in for friction. If it's barely held stationary, plug in F max equals the friction force and set acceleration equal to 0. If it doesn't say whether the object is moving or standing still, that's where you go through this process I just described. Assume stationary, calculate FF, calculate FN, calculate F max, compare F max to FF, and then determine whether static friction is correct or incorrect. And then if it's correct, you're fine. If it's incorrect, start over. And that's the basic process for how to tell whether you're doing static or kinetic friction.